My name is Danielle. I'm part of the Flatcar team and Microsoft. And today I want to talk about how you could leverage your work in order to contribute upstream using Flatcar as an example, and how that work leverage us to be part of the CNCF foundation. So let's talk first about what is Flatcar and what's the idea behind it. So you want to deploy another server, and then you think to yourself, what should I do? There are so many options, and the landscape is full of options, and yeah, which way should I go? So you can go to the general purpose Linux distributions, or go with a container optimized Linux. Part of that is the first company that started this approach was CoreOS. So, So the first company that started that was CoreOS. Their approach put the foundation for what later came to be the container Linux. So how does that work? It's a minimal distribution system for containers, meaning that they took all the packages that you don't need there and just kept the minimal, like 95% of them are off. And that basically minimized the attack surface. That is leveraging the security for the operating system. I'm sorry, I'm really nervous about public speaking. So, do you ever read the only operating system, which the image base is read-only? That means that you cannot tweaker with that. You cannot have any snowflake configuration. People associating doing stuff that kind of make your life harder later to maintain. So part of that, you have the image base, right? So it is comes as one partition that you could switch between with A/B partitioning, and that allows you to have secure updates without any manual intervention. So you could just switch between the two operating systems. You can fully automate it, choose when you want to have the new update coming. You could do it also manually decided. So it just creates a much easier life for you as someone that needs to maintain that system. And we do it in a declarative way. So you just kind of have a JSON file that you later compile, which include everything you want to go, and you forget about it. So if we look at how Flatcar came to place, sorry about that. So it stands on heritage that comes from different projects that came before. So the base of Flatcar is based on Gentoo. So that's how we get packages, the minimal packages that we maintain. It's we get them as an e-build and a script repository. So it's slightly different, but every time we build an image from scratch and we test it on extensive scenarios. We have more than 100 scenarios, and for each one of them, almost, not the ones that are cascading, we create a new image. So for every release, just start over. And we also for the A/B partitioning that I mentioned before, it comes from Chrome OS. So Google started it with Chromium, so all of that history was what Container OS started about, and then later they were acquired by Red Hat, that was later acquired by IBM, and we came to the picture and we said, okay, let's make a fork of that. And that happened quite a few years ago. So, but we maintained it, and we also added a lot of things in the meantime. So we kind of have the same approach, and where it goes from there. So the advantage of using that approach is basically you declare once and you forget it. So it's like if you have a cake, you basically read a recipe and the cake makes itself. And the cake is your operating system. Now, when you decide where you want to go, you have the option of going for general purpose Linux. And with that comes some, you have a lot of freedom. You could do whatever you want, but maintaining that is, let's say, could be suboptimal because you need to create a lot of scripts, create a lot of automations around it, just to get to the point of the automation that you have and easiness of that Container Linux would give you. Basically, that could create instances where you have just different configuration for the different servers and a lot of headaches for your maintainers, so for your DevOps. So then came the special purpose Linux on top of that, right? And that with this declarative approach, you don't need to think about it. But what happens if you have a different use case? A use case that requires that your base image that your would be modified to whatever, something that you cannot containerize and run in your distro. So we thought about it. We got a lot of requests, and we came to an approach that leveraged systemd sysx. And the advantage of that is that you can basically modify your base image without really touching it, because it's still read-only. So you stack upon it something else, another layer. And then you have the composable Linux. Basically, it's another layer that comes on top that allows you to achieve the usage that you want. So this is like a lot of words that I threw here. It would be easier if there would be some example to kind of explain that. By the way, there's a talk today at 4. I'm not going to be going for all the technical details, but there's a talk today at 4 about where the future of container-optimized Linux goes to, how the next 10 years is going to be, and a lot of demos, 2 demos, to color that also. And that's at 4 at P1, at K1. Okay. I'm sorry. Yeah. So you stack upon it another layer, which is the systemd system extensions. And what it does, it's another partition, read-only, with a symlink, that you have a source, which is basically a URL, and they check a raw file and its hash. And if there is a change, it fetches us and put it in the location that you declared in the other layer. So basically, you put on top of the base image another layer that extends your usability. And how does it look like when you use it at Flatcar? So you have the declarative file, which is the YAML, which is still a human file. Then you transpile it, get a JSON file, and during boot time, that configuration comes into play. And you could also add a system extension there during the declaration. And that will allow you to have more use cases covered. And that's how the file looks like. You have the path, where it goes from and where it goes to. So quite easy to declare. And there's a bakery with pre-made files that you could use, pre-made system extensions. So you don't need to start from scratch for every use case. And we are always happy to get contributions if you have something that is not. That work was quite specific for Flatcar at the beginning because it required that the immutability of the file system. So basically, it worked only on read-only Linux distributions. But we contributed upstream and implemented an option of mutability for extensions. So now you could take a general purpose Linux and use that if someone chooses to continue that work. But it creates the path here. So it's, how we see it, it's an elegant way to extend your system while keeping it clean. So that work later allowed us to, we had also a cluster API. Everyone is familiar with that? Okay, maybe I would just say a word about cluster API. So it's a way to provide clusters, Kubernetes clusters in a declarative way. And you have different providers for that. And for each provider, you have also a combination of the images that you want to have. So like for each build that you create, you need to take the Kubernetes version, you take the stack distro image, combine them together with the image builder, and then that's created the distro that would later you could use during provision time. So that means that you have like a matrix of complexities here. The Kubernetes version and the different stack distro images and the different providers. So it's like almost like you could look at it as a three-dimension matrix, which it creates a lot of overhead when you want to use CAPI. So, hey, if we have this like approach that is stackable, why not use it here? So that's how it looks later during deployment. Basically, you take each one of these images that you created with the image builder, and that goes to your worker nodes. Right, and then as someone that contributes to this, to CAPI and create the images, that's how it looks like. You have a lot of different distribution, each one of them, each image here have a different flavor of Kubernetes and the base OS image. So I think you know where I'm going with that. And why not simplify it and decouple? So you have the stock distro image. On top of it, use system extensions that will decouple the two and will allow in-place updates. Because basically you could just restart the node and you have a new fresh Kubernetes version. And that creates a lot more elegant way to approach it, in my opinion, in our opinion. So that's already demonstrated on OpenStack, and we're working also to get it on Azure. And that leads me to a new concept, container karma. So karma is like, you know, if you want to phrase it, it's like what you give is what you get, right? So if you have good deeds, good would come back to you. And how that manifests in open source. So we have the Dharma wheel, of course, of Kubernetes, but that's not what I'm talking about. So let's take the example that I just presented. We contributed to other projects, like systemd, and to upstream Gentoo, and to also CAPI. So you have a lot of interface with different projects when you want to achieve something like that. So that creates collaboration between different groups. And also, like, let's take CAPI. So you have the different providers. So even there, you have different collaborations. And then people are like interested in Flatcar, contribute back, right? So it just like create more interface with different communities. And then you build a community around that, around your project. And one of the things that allows that is just make it simplified for people who wants to contribute to be able to contribute. So I'll take the example of Flatcar. We have all the development in the open. So we have a project board where we say what we want to do. Everything is on GitHub. We have a developer sync, and we have a monthly office hours, so 2 meetings that are in the open. And all the development work is on metrics. So basically, if you want to just be part, you can, because everything is out there. There's also like other work that was done on this script repo to make the path for contribution easier. So like if you want to run Flatcar locally, you can do it much more easily now. So a lot of automation that took place there. Also to create easier testing, and still in progress. So when you work like that and you work with other projects, that getting recognized, and that leads to more contribution and more collaboration and growth of the community. And that's the container karma. So how did it look specifically at Flatcar? We contributed Flatcar to CNCF. That's something new this month, officially. We're in incubation, skipped sandbox directly to incubation. So that's the new era, and that opens a lot of more collaborations. It ensures that our original vision stays as it is, right? Because Flatcar stays true to its goal, and everyone could now be a maintainer, and also before everyone could have been a maintainer, but now it ensures that it belongs to the community. That work with CNCF kind of steered the way. It's the first operating system that is in CNCF. It was like a process to get it there, because when you get it with the operating system, there's a lot of licenses that comes with an intellectual property. So it took some time, but we're there. But we're not alone, right? There are other container Linux or special purpose operating system out there. So we created a working group around it. And the idea is that you have different vendors from different companies sitting together, meeting together monthly, have a Slack channel together, and just see what we could collaborate with together. So create a white paper, see if there's any approaches between them that we could find a common ground between, and so on. So these are the members. Like not everyone, Talos actually didn't present it yet. But if you want to see like this special purpose OS working group, you could just come. We meet monthly on the third Thursday of the month, 2:30, 4:30 German time. 2:30 GMT, that's what I was looking for. So personally, through that, like I'm the PM for Flatcar, so I worked a lot with CNCF. So I got to, I was one of the people who steered this special group. And that also later led to an opportunity to be part of the CNCF TAG-Runtime. So I'm co-chairing both. And the TAG-Runtime got a bigger scope. It basically touches everything that you run in, that has to do something with CNCF, sort of. But because it's like the goal is to enable adoption of workload, whatever they are, right? So the scope is quite vast. You could find a way to contribute or your special interest. Just gonna list the different groups that we have, and give you a taste of the landscape that we are part of. And there's a range of projects that are part of it. And the landscape is even vaster because it, as I said, touches a lot of different areas. Now, if you want to be part of that and contribute, there's many ways that you could do it. So I'm just going to propose a few, but I proposed in a linear line, but it's definitely not linear. So what you could do is find projects that you're interested in and present, like offer them to present. Just like usually how we do it, we just go to the GitHub and write something there. If you're not sure if it's like a project that is suitable, you can just like go to the Slack channel and say, hey, what about this? What about that? Just, just get involved. That helps because like it's a landing point to the TAG-Runtime, and from there we could just like tell them, hey, we think you should present also here or there. So you can attend these meetings, offer projects to join and present them, and there's also white papers for the different working groups. And that's also something that your contribution would definitely kind of pave the way there. And there's like different initiatives, for example, sandbox reviews and different reviews that we have for the different projects here on a yearly basis, ContainerDays, sorry. And yeah, that could also lead later to leadership position in CNCF. And that was my story of the container karma.
Thank you so much. I really enjoyed the focus that you had on getting involved and getting involved in the CNCF. I was wondering, like, for me, it seems like you have to be like really super, super clever and like a super expert to be able to contribute. So you're saying that there's space for everyone. I think that's a really lovely story.
Yeah, I could say personally that I always feel like the less technical person in the room is I'm not a TPM, I'm a PM. However, if you show up and you're willing to do the work, whatever it is, it doesn't have to be like contributing code. It could be like organizational skills or just making sure things would happen in the right cadence, or yeah, giving talks when you're totally socially awkward about it.
You've done a wonderful job. Don't say that. One question is, what programming language can people use to contribute to Flatcar?
Not the right person to ask, honestly, but yeah, either to contribute to Flatcar specifically?
No, they said just to contribute, but I think it's to Flatcar.
Okay, I guess that I cannot answer that.
We can figure it out. It's a good question.
We could take it offline.
The next question is, in the past, support for cryo was not really there in Flatcar. Did this change with the system D6X that you showed?
I'm sorry, I didn't get the first half.
Support for cryo was not really there.
Is that change?
The Kubernetes container runtime, yeah.
No. Did it change, Andy?
Yes, there's a cryo.
Oh, wait.
In the bakery.
Can you repeat the
Sorry.
microphone, please?
Yeah, there's a cryo sysexed in the bakery, so you just specify that on your provisioning, and you get cryo in Flatcar.
Wonderful, thank you so much. There's one more question, 2 seconds. Someone gave you a compliment. I'm going to put it on the screen so you can see. Great talk, good job on public speaking. You did great. See, that's so lovely.
Thank you.